Assalamu alaikum and welcome to a new presentation. Today, I am going to discuss about how to create some nutritional indicator from BDHS data such as stunting, wasting, and underweight. Generally, uh, stunting refers to chronic malnutrition. Stunting, wasting means acute malnutrition, and underweight means undernutrition. Now, in STATA software, how to create this indicator from BDHS data? For learning purpose, we will open the BDHS 2018 data. There are several of data sets for the BR, ASR, KR, generally to estimate the prevalence of stunting, wasting, or underweight, we use PR, just PR. This is PR data set. But to know how to create this indicator, we should follow the instruction from DSS guideline. Go to Google and DSS program, then data, guide to DSS statistics. We have to click here and type stunting. Okay, stunting. Then, what is the definition of stunting from BDS based on BDS data? Now, for this scenario, we have to use this variable. That means sleep at night. What is the definition? That means for inclusion criteria of this analysis, that means we have to keep ASV 103 is equal to 1. That means keep if 1 and that means the inclusion criteria is ASB 103 is equal to 1 and C1 means age in month, age below 59 and below or equal 59. Click. Sorry, double. That means if we yes 59. And another issue is that since DSS data is the national representative data, therefore we have to adjust the sampling weight. In this data set, this is the sampling weight. This is the sampling weight, but household sample weight 6 decimal place. That means we have to divide it we have to divide it. That means then SWT, the sampling weight, is equal to divided by 6 decimal place mean 1 n 1 2 3 4 5 6. This is the sampling weight. Now we have to create the variable stunting. Stunting variable create from height for z score. Then height for z score. Height for z score. The name of the variable. This is the height for s. This is the height for s. This is weight for s. Weight for s. And this is weight for height. Weight for height. And also and is order. Then the variable seen in the first. The height for weight, that means has. Weight for s. Height for s has. Weight for s was. Weight for height WHZ. But BR 5.59 295 182. This is the very last one. That means the indicator with 2 decimal place. 2 decimal place. For example, the sampling weight, please see that the household sample weight is the 3 decimal place. Similarly, the z score variable is 2 decimal place. Therefore, we have to create a new variable. For example, then has is equal to height for s divided by 100. Since 2 decimal place, so that we have to divide by 100. Then similarly, then was is equal to weight for s divided by 100. Then WAZ is equal to this is was an wasting variable created from this indicator. Now, if we order and if we browse has was WZ, yes, now it is okay. Has 1.0 minus 1.37 minus 2.97 etc. Now we have to see that the range of the indicator. Range means just sum. Please type sum and press enter. The minimum value is 5.86, maximum 99. That means 99. This is not the value of S. This means the other don't know or flag or not applicable, etc. Then we have to remove this value 99.98. That means we know that for survey data, the maximum value of has, was, or WZ is +6 or 5. For has, the maximum value is +6. For WZ, the maximum value is 5. We have to replace the value. That means replace by missing. That means if we replace by missing simultaneously for var or just replace has is equal to dot if has less than 6 was WAZ WAZ. Now sum. Yes, this is the maximum. Now it is okay. So we copy it in the do file. Do file. Do file. Okay. Now we have to create a variable stunting. The definition of stunting is then stunting সমান 1 if has less than -2 replace stunting is equal to 0 if has -2, and we have to give another condition, missing if is equal to missing. Now label define stunting stunted. 1 means stunted, 0 means non-stunted. Replace label value stunted. Okay. Now tab stunted, that means 31%, but it is unweighted. If we address weight, then just tab third bracket I weight is equal to sampling weight or simply with SWT. That means the prevalence of stunted is 30.84. And if we compare with our report, BDHS report, then BDHS report, this is BDHS report, chapter 11. This is stunted. Percentage age below -2 stunted deviation is stunted, and the value is 30.8. 30.8. The value of the prevalence of stunted is 30.8. 30.8. We also found 30.8. The N is 8108. 8108. That means our analysis is okay. Similarly, we can calculate the indicator wasting, underweight, and other nutrition status. For example, if we calculate the stunting, wasting, just wasting, and WAZ, wasting, and just run, and the value is 8.43, and go to the wasting value is weight for height minus SD 8.4. Yes, 8.4, and N is 8113. 811 if we consider rounding, if 8113. That means the indicator of wasting also okay. Similarly, we can estimate the other indicator, for example, underweight. Underweight. UN underweight. Underweight. Was and run the syntax. 21.9. 21.9, 100% mass, and 8335. 833 if we consider the rounding 5. That means the indicator also okay. So dear audience, in this procedure we can easily estimate the prevalence of stunting, prevalence of wasting, and prevalence of underweight. But this is for only estimation purpose. But if we run the regression analysis or other analysis, then we have to open KR data set. There are several data set. That means the BR, HR, KR. Now I use the PR, that means the household member data set. But if we analyze regression analysis or other analysis, then we have to use KR data set, just KR data set. And using same procedure, we have to create the indicator wasting, underweight, and stunting. And this is the do file. So dear audience, thank you for watching this video.